Today more than ever, individuals depend on the network to live, learn, work, and play. As a result, it's critical that networks have built-in redundancy in order to reduce the probability of network downtime. Spanning Tree Protocol, or STP, is a protocol designed to prevent Layer 2 switching loops, which can occur when redundancy measures are implemented in the LAN. In this animation, you can see that trunk 1 is used to deliver frames from PC1 to PC4. However, notice there's another possible path that uses trunks 2 and 3. If trunk 1 fails, the alternate path automatically is activated to reduce network downtime. The mechanism that enables this to occur is Spanning Tree Protocol. STP is necessary because when introducing redundancy at Layer 2, logical switching loops can occur. You'll notice too that once trunk 1 is back up, then that automatically gets re-enabled as the most efficient route from PC1 to PC4. At Layer 3, IP packets have a built-in loop mitigation mechanism called time to live, or TTL. If an IP packet is involved in a loop, eventually the TTL decrements to 0 and the packet is dropped. Unfortunately, there is not such a mechanism built into a Layer 2 frame, and as a result, if a Layer 2 loop occurs, it will continue endlessly until switches in that loop are power cycled. STP was developed to allow the existence of physically redundant loops in a switched LAN while preventing logical loops. Although beyond the scope of this presentation, Layer 2 loops can occur through broadcast storms, switch MAC address table instability, and LAN cabling issues. Symptoms of switch loops include duplicate unicast frame delivery, reduced bandwidth availability, and even network failure. STP mitigates loop formation by allowing traffic to travel only one path from a source to a destination on the LAN, even though there are multiple physical paths. STP accomplishes this by disabling specific ports within the redundant switch fabric. Essentially, there may be many available ports to get from a LAN source to a LAN destination, but only one path is active. As seen in this animation, if the primary path fails, the ports that make up the redundant path are enabled, thus restoring network functionality. Now that you know the purpose of STP, let's learn some more of the functionality of the protocol. The first step that occurs in STP operation is the election of a root bridge. The root bridge serves as the reference point for all other switches in a LAN. Although the root bridge is called a bridge, it is actually a switch. This reference point enables the other switches to know their place in the LAN topology. The switch with the lowest bridge ID is elected as the root bridge. The bridge ID, or BID, contains a priority value which is the MAC address of the sending switch, and an optional extended system ID. The lowest bid value is determined by the combination of these three fields. After root bridge election, other switches in the topology must find the most efficient Layer 2 path from LAN sources to LAN destinations. This decision-making process is done by assigning throughput-based cost values to ports that make up a Layer 2 path. The path with the lowest accumulated cost from a destination to a root bridge becomes the primary path. Other higher cost paths are disabled to prevent switching loops. If the primary path fails, the alternate path is enabled automatically. As we look at this graphic, we see that our root bridge was elected as such because of its priority value of 27,577, which is lower than those of the other switches. If we assume that all the links are the same throughput rate, we can easily see that the best path from switch 2 to the root bridge, switch 1, is through trunk 1. However, STP uses the cost values of these trunks to make its decision on the best path. Because the links are 100 megabit per second Ethernet, each trunk has a cost of 19. When the two different paths' costs are calculated, path 1 is determined to be the preferred path because of its lower cost value, which is 19, compared to path 2, which has a cost of 38. After the best path to the root is selected, switch ports begin taking on specific roles. The root port is the one port on each non-root bridge that is the best path to the root bridge. Root ports forward traffic to the root bridge. Designated ports exist on both root and non-root bridges. All ports on the root bridge are considered designated ports. However, on a non-root bridge, a designated port forwards traffic toward the root bridge but does not connect to the least cost path. Because it does not connect to the least cost path, the port on the other end of the link is blocking traffic. This blocked port is called a non-designated port and breaks any logical loops in the topology. Since its introduction, STP has evolved into many different forms, each enhancing its capabilities. Variants include Rapid Spanning Tree Protocol, or RSTP, which has improved convergence times over traditional STP, and Cisco's own Per VLAN Spanning Tree Plus, or PVST Plus, which enables multiple instances of STP to run on separate VLANs for Layer 2 load balancing purposes. We highly recommend you familiarize yourself with all the versions of Spanning Tree Protocol so you can make the best possible choice when implementing the technology on your network. Switching loop prevention through proper implementation of STP is critical when a redundant switch topology is deployed.